Electronics. For all. Be warning. This video for scientific only. Be careful if you try to do it at home. Hello everyone. And welcome back. In this video, we will talk about an important circuit, uses in almost expensive audio devices and many electronics devices and applications. The objective of this project is to convert 220 volt AC supply into plus 12 volt and minus 12 volt DC supply. That is why it is named dual power supply, as we get positive and negative 12 volt power supply at the same time. This can be achieved in simple 3 steps. Firstly, 220 volt AC is converted into 12 volt AC by using simple step-down 220 volt to 12 volt transformer. Secondly, output of this transformer is given to the rectifier circuit, which will convert the AC supply into DC supply. The output of the rectifier circuit, that is DC, contains the ripples in the output voltage. To filter out these ripples, capacitor is used. Lastly, the output of the capacitor, that is pure DC, is given to voltage regulator IC7812 and IC7912, which will regulate the output voltage at plus 12 volt and minus 12 volt DC. Despite the change in input voltage. Required components: center tap transformer 220 volt to 12 volt, power diode 6 ampere, capacitor 2200 microfarad, 25 volt, voltage regulator, IC7812 and 7912. Constructing dual power supply circuit. Step I. Converting 220V AC into 12V AC using step-down transformer. The primary terminals of the center tap transformer is connected with household supply 220 volt AC, 50 Hz. An output is taken from secondary terminals of the transformer. The center tap describes the voltage output of a center tap transformer. For example, a 24 volt center tap transformer will measure 24 volt AC across the outer 2 taps, ending as a whole, and 12 volt AC from each outer tap to the center tap, half winding. These two 12 volt AC supplies are 180 degrees out of phase with each other, thus making it easy to derive positive and negative 12 volt DC power supplies from them. The advantage of using a center tap transformer is we can get the both plus 12 volt and minus 12 volt DC supply using only one transformer. Input equals 220 volt AC at 50 Hz. Output, between outer terminal and middle terminal, equals 12 volt AC at 50 Hz. And between the 2 outer terminals equals 24 volt AC at 50 Hz. The outer 2 terminals of the center tap transformer are connected to the bridge rectifier circuit. Rectifier circuit is a converter, which converts AC supply into DC supply. It is generally made up of diode switches as shown in circuit diagram. To convert AC into DC, we can make 2 types of rectifiers. One is half bridge rectifier and second is full bridge rectifier. In half bridge rectifier, output voltage is half of the input voltage. For example, if input voltage is 24 volt, then output DC voltage is 12 volt and number of diode used in this type of rectifier is 2. In full bridge rectifier, number of diodes is 4 and it is connected as shown in figure, and output voltage is same as the input voltage. Here, full bridge rectifier is used. So, number of diodes are 4 and input voltage 24 volt AC, and output voltage is also 24 volt DC with ripples in it. In this dual power supply circuit, diode bridge rectifier is made up of 6 ampere 4 power diodes. Rating of this diode is 6 ampere and 400 volt. It is not necessary to use this much of high current capacity diode, but because of safety and flexibility purpose, high current capacity diode is used. Generally, because of surges in current, it is possible to damage the diode, if we used low ampere rating diode. The output of rectifier is not pure DC, but it contains ripples in it. Now, 24V DC output which contains peak-to-peak ripples can't be connected directly to the load. So, to remove ripples from the supply, filter capacitors are used. Now, two filter capacitor of rating 2200 microfarad are used as shown in circuit diagram. The connection of both capacitors are such that the common terminal of the capacitors is connected directly to the center terminal of the center tap transformer. Now, this capacitor will get charged up to 12 volt DC as both are connected with the common terminal of a transformer. Furthermore, the capacitors will remove the ripples from the DC supply and give a pure DC output. But, the output of both the capacitors are not regulated. So, to make the supply regulated, output of the capacitors are given to the voltage regulator ICS, which is explained in next step. Input, 12 volt DC, with ripples, not pure. Output, voltage across capacitor C1 equals 12 volt DC, pure DC, but not regulated. Voltage across capacitor C2 equals 12 volt DC, pure DC, but not regulated. The next important thing is to regulate the output voltage of the capacitors, which will otherwise be varying as per the input voltage change. For that, depending upon the output voltage requirement, regulator ICS are used. If we need the output voltage plus 12 volt, then IC7812 is used. If required output voltage is plus 5 volt, then 7805 IC is used. Last two digits of the IC gives output voltage rating. Third last digit shows voltage is positive or negative. For positive voltage 8, and for negative voltage 9 number is used. So IC7812 is used for plus 12 volt regulation and IC7912 is used for minus 12 volt voltage regulation. Now connection of two ICS are done as shown in circuit diagram. The ground terminal of both ICS are connected with the center tap terminal of the transformer in order to create a reference. Now, the output voltages are measured between the output terminal and ground terminal for both ICS. Input equals 12V DC, pure DC but not regulated. Output equals plus 12 volt DC between output terminal of 7812 and ground, pure DC and regulated. Minus 12 volt DC between output terminal of 7912 and ground, pure DC and regulated. Applications of dual power supply circuit. Operational amplifiers need two power sources, usually one plus volt source and 1 volt source. Because the operational amplifiers must operate in both polarities of the incoming signal. Without the negative source, the operational amplifiers won't swing into action during the negative cycle of the signal. So that signal portion's output will clipped, that is, remain at ground itself, which is obviously not recommended. If DC motors are used as a load, then for plus 12V it will rotate in clockwise direction and for minus 12 volt it will rotate in opposite direction. Check our other power supply circuit. 0 to 24 volt 3 ampere variable power supply using LM338. 12 volt battery charger circuit using LM317, 12 volt power supply. Transformer-less power supply. DIY power bank circuit. Cell phone charger circuit. Hope you enjoyed the tutorial and learned something useful. If you have any questions, leave them in the comment section. Thanks for watching. Follow us on all social media. If you enjoyed this video, please like it, subscribe, and click the bell icon to get new video updates.